So welcome to our video tutorial. For this tutorial, we will tackle about integration of exponential functions. So for integration of exponential functions, we have two formulas. Okay, so first one, we have integral of a raised to u, where a here is equal is not is they call this is greater than 0 but not equal to 0, or not equal to 1 rather. Okay, and integral for that is a raised to u over ln of a plus c. And for the second one, we have integral of e raised to u du, which is equal to e raised to u plus c. So if you try to recall that the derivative of e raised to u is equal to a raised to u, okay, which makes sense because if you integrate it will still equal to e raised to u, right? Okay, so let's try to solve example problems for this one. So let's say we have this integral of 3 raised to tan 4x times secant squared 4x. So for this one, in order for us to solve this, before we integrate, you should know already about method of substitution like du sub, right? And also you need to familiarize the derivatives of trigo functions. Okay, so for our solution here, so I will let u equal to tan 4x, okay, because I know the derivative of tangent, that is equal to secant squared, right? So this will become du, the derivative of tan 4x is equal to 1/4 secant squared 4x, and then dx, okay, right? And since here our integrand only contain this secant squared, okay, and here we have 1/4 here, we don't need this 1/4, okay, we need to eliminate that 1/4 so that we can isolate the secant squared for x. So I can try to multiply both sides by 4, so that if I solve for secant squared for x, it is simply equal to 4 du. Okay, so after that we need to write this in terms of u. So this will become integral of 3 over tan 4x, that is equal to u times secant squared 4x dx is simply forgot the dx pala, there should be dx here, it's equal to 4 du. Okay, like that. So this will become 4 du. And since we have a constant here which is 4, we can put that before the integral sign. So this will become 4 integral of 3 raised to u du. And for the integral of this one, we know that is equal to simply 4 times 3 raised to u over ln of 3, right, plus c, which our a here from the earlier from the what they call this formula earlier, we have a raised to u, right, which is yung a is yung constant. After that, we just need to plug in back the what they call this, the original value of u, which is equal to tangent 4x. So this will become note that we cannot combine 4 and 3, so this will just become 4 times 3 raised to tan 4x over ln of 3 plus c. Okay, so there's no further simplification, so for our final answer will be this one. So for our second problem, so that is our second problem will be integral of e raised to 4 minus 3x dx. Okay, so this is our second problem. So still we need to use a substitution method. Okay, so our solution will be, I will let u this equal to 4 minus 3x. Okay, that is our u, this one. So I will let u equal to 4 minus 3x. After, you just need to differentiate it. So this will become derivative of 4, which is constant, and then we need to focus na lang for this negative 3x which is equal to negative 3 dx. Okay, and since for our integrand we only have here the x, we don't have a negative 3, so I will divide both sides by negative 3. Okay, so that my dx is equal to negative of du over 3. Okay, after, we can rewrite this as we can rewrite the integral in terms of u. So this will become, let's put another page. Yeah. Integral of e raised to u, because our exponent is u, times you have negative of du over 3, which also I can put this negative 1/3 here before the integral. So this will become negative 1/3 integral of e raised to u du, right? So since there's no space, let's put it here. After, you just need to integrate it, right? Integral of negative 1/3 times integral of e raised to u is simply e raised to u, right? And then plus c. After, we just need to plug in back the value of u in terms of x, which is equal to 4 minus 3x plus c. So there's no further simplification, so therefore this is now our final answer. Okay, now let's proceed to number 3. So for the number 3, we have integral of x raised to negative 2 times e raised to negative 1 over x dx. Okay, so for this one, we still need to use substitution, right? Wait, let me, like that. And what do you think will be our u? So for this one, I noticed that if I try to let u equal to this negative 1 over x, that will be our u. Okay, because if you try to differentiate this one, du is simply equal to, this is equal to 1 over x squared dx. Okay, but here for our integrand, we have x raised to negative 2, but this one, 1 over x squared, is also equal to x raised to negative 2 dx. Okay, these are just equal, so this will become integral of e raised to u, and which is this one, x raised to negative 2 dx is equal to du. So this will become du, which is simply equal to e raised to u plus c, or in terms of x, that is equal to e raised to negative 1 over x plus c. Okay, so this is now our final answer. let's proceed to number 4. So for our number 4, we have integral of e raised to 3x cube root times cube root of 4 minus e raised to 3x dx. For this one, we still need to use substitution, right? So I will let u equal to 4 minus 3x, okay? Because if we try to differentiate this one, this will just equal, no, I forgot. This is not 3x, e raised to 3x rather, my bad. E raised to 3x. Ayun, okay. So if we try to differentiate this, 4, the derivative of that is just 0, and this one, negative e raised to 3x, is simply equal to negative of 3 e raised to 3x dx, right? And we don't have negative 3 here. This is just our present, right? These two. So therefore, in our du, we need to divide both sides by negative 3, which is this will become e raised to 3x is dx is equal to negative of du over 3. Okay? So after, we write this in terms of u. So this will become integral. This one is du, right? This will become cube root of u. This e raised to 3x and this one is equal to du. Negative du over 3. Okay? I can put the negative 3 before the integral sign. So this will become negative 1/3 integral of cube root of u. We can write that in terms of exponent fraction form. So this will become u raised to 1/3 du. And we just need to apply integration, power rule of integration. We need to add 1 to its exponent, and at the same time, we need to put its power to sa denominator. Ayan. This will become u raised to 1/3 plus 1 over 1/3 shibal 1/3 plus 1 plus c, which basically equal to 1/3 plus 1 is 4/3. So this will become negative 1/3 times u raised to 4/3 over 4/3 plus c. Okay? I need more space. Let's make this as okay. Yan. Sige. After, we can simplify this by cancelling out this 3, which will left na lang as negative of 1/4 u raised to 4/3, which will be equal to our original value of u, that is equal to 4 minus e raised to 3x. So this will become I forgot the plus c, my bad, plus c, which is equal to negative of 1/4 4 minus e raised to 3x raised to 4/3 plus c. Okay, So since there's no further simplification, this is now our final answer. But you can transform this into radical form if you want, okay? But this is still acceptable. This is our answer here, okay? It's up to you. So let's have number 5. So our number 5 would be we have integral of e raised to 2x minus e raised to negative 3x raised to 2 dx. So for this one, we just need to expand this first before we integrate, okay? Because we cannot have a substitution for this one directly. So we need to expand first before we can substitute. So we know if you try to expand, let's say a plus no, that is minus rather, we have a minus b raised to 2, that is equal to a squared minus 2ab plus b squared. Okay, so let's say our a here is the e raised to 2x and our b is equal to e raised to negative 3x. So therefore e raised to 2x minus e raised to negative 3x raised to 2 is simply equal to e raised to 2x raised to 2 minus 2 e raised to 2x times e raised to negative 3x plus e raised to 3x raised to 2. Okay, wait, let me fix this. E raised to 3x raised to 2. Okay, after, if we have a power to power, we just need to multiply it, right? So 2 times 2x is simply equal to e raised to 4x. And for this one, the same bases, okay, the same base rather. So we have e and e. We just need to add their exponent. So 2x plus negative 3x is simply equal to negative 2 e raised to negative x. Okay, and for last term, we have 3x times 2, that is equal to e raised to 6x. Okay, after, so I will rewrite this as integral of e raised to 4x minus 2 e raised to negative x plus e raised to 6x raised to times dx. This, guys, I have a trick, guys, for general let's say general integral. So we know that the integral, let's say integral of e raised to u du is equal to e raised to u plus c, right? But what if, let's say, you have a constant, let's say this one, integral of e a u du, let's say this a is the constant, okay, constant term. So that would be equal simply to 1 over a times e raised to au plus c. Okay, so that we don't need to use more substitution because we have a 3 terms here, right? So we just need to think of this one. So if we have a constant, let's say 4, we just need to copy this e raised to 4x term and then just put the reciprocal of 4, which is equal to 1/4. Okay, so again, let's apply that. Before that, let's separate or distribute the integral sign together with the dx, okay? So this will become e raised to 4x dx, and for the second term we have negative 2 integral of e raised to negative x dx, and lastly plus integral of e raised to 6x dx, okay? So let's apply this one. So for the integral of e raised to 4x, so our constant is 4, so just take the reciprocal, which is equal to 1/4, okay? And copy the term e raised to 4x minus 2. For this one, since our constant here is negative only, okay, reciprocal of negative 1 is still negative 1. So this will just become negative 1 or negative e raised to negative x, okay? And plus, for the last term we have 6. Reciprocal of 6 is simply 1/6, okay? And then copy the term e raised to 6x. And then, since we are done integrating, we can now add plus c. That's it, right? Very easy. So let's just simplify this. This will become 1/4 e raised to 4x. So negative 2 times negative 1, this will become positive. Actually, you can also simplify this by putting by making the e raised to negative x as positive exponent. So we can put that into denominator. So this become 2 e raised to positive x na, okay? Plus 1/6 e raised to 6x, and then plus c, okay? So this is gonna be our final answer. Sige, let's go with our next item. That is number 6. Number 6. So we have here integral of 8 raised to 1 minus 2 x squared and then x dx. So very simple, right? We just need to let u, or substitution. So I will let u equal to 1 minus 2x squared, because if we differentiate that, it is simply equal to negative 4x, okay, dx. But we don't have here negative 4 dito sa here for our integrand, which is only x dx. So to solve for x dx, you just need to divide that both sides by negative 4, which is equal to negative of du over 4, okay? Next, let us rewrite this in terms of u. So let's have this here sa right side. So this will become, we have negative 1/4, which is the constant earlier, integral of 8, and then this will become u times du, okay? Which will be, the integral of this is simply equal to negative 1/4 times 8u over ln of 8 plus c, okay? And after, just need to bring back the u in terms of x, which will be equal to 8 raised to 1 minus 2x squared over 4 ln of 8, and then plus c, okay? So this is now our final answer. Okay, let me fix first. Excuse me. Okay, Okay, very good. So for our next problem, which is number 7, we have a definite integral. So integral from from 0 to 3, integral of quantity 4 minus e raised to negative z z. Wait, my z looks like 2. Let me clear this one. Yan, z raised to 2 with 2. Yan, dz. Okay, that is z ha, not 2. Let me okay, so for this one, we just need to expand this. Okay, like earlier we did so if we have a minus b, okay, raised to 2, that is simply equal to a squared minus 2ab plus b squared, right? So here our a will be 4, and then our b is negative e raised to negative z. Okay, so this will become, so our 4 minus e raised to negative z simply equal to 4 squared is 16, and then we have negative 2 e raised to negative z plus e raised to negative z is simply equal 4 times e raised to negative z is equal to 4, but we still have 2, so it will become 8. Okay, so this will become 8 e raised to negative z. No, don't do that. Yeah. And lastly, e raised to negative z squared, that will become e raised to negative 2z. Okay, because if you have a power to power, you just need to multiply it. So our new integral integrand will become integral from 0 to 3, 16 minus 8 e raised to negative z. It looks like 2, so confusing. Yan, z plus e raised to negative 2z. Okay, dz. Next is we just need to integrate each term. So this will become 16z plus 8 e raised to negative z, and then this will become negative 1/2 e raised to negative 2z. Evaluate it from 0 to 3. So after that, we just need to plug in our upper limit minus the lower limit. Okay, so first plug in the upper limit. This will become 16 times 3 plus 8 e raised to negative 3 minus 1/2 e raised to negative 2 times 3 minus, okay, this is our upper limit, minus its lower limit, so this will become 16 0 plus 8 e raised to 0. We don't have space. Wait, I will put it na lang sa ubos. Then minus 1/2 e raised to negative 2 0. Okay, So 16 times 3, that is equal to 48. And then this will become plus 8 e raised to negative 3. This one here, negative 2 times 3 is equal to negative 6. And 16 times 0 is 0. And 8 times e raised to 0, any number raised to 0 is equal to 1. So this will become negative 8 after e raised to negative 0 or 0 to, so that will become 0 lang, 1 pala. So positive 1/2. Okay, next we can try to add first the numbers, I mean the 48 and 8, that is equal to 48 minus 8 is 40 plus, I will put 1/2, and here I can also combine the, what we call this, combine these exponential functions or terms. This will become 2 16 e raised to negative 3 minus e raised to negative 6. Okay. And I can combine the terms or the common fraction in using the LCD, or just add the fractions. This will become 40 times 2 is 80 plus 1 plus 16 e raised to negative 3 minus e raised to negative 6 over 2. Or 80 plus 1 is simply equal to 81, right? Let's just put that as 81. Okay, so we cannot simplify further. Let's have this as our final answer. So you can try to check sa calculator if we have the same answer. Okay, so for our last problem, we have number 8. Black. Yan. Integral of 5 raised to 2x over 5 raised to 2x minus 1 raised to 3 dx. Okay, so for this one, how can we integrate this? So still the same, we need to have a substitution. So for this, I will let u equal to 5 raised to 2x minus 1. So how can we differentiate this? The derivative of exponential function like this is that is equal to d over dx of a raised to u is simply equal to copy the a raised to u times ln of a and then the derivative of u, okay, and with respect to x, like that. That is the derivative for a raised to u. After, so let's apply that formula or equation, formula. So our du is simply equal to 5 raised to 2x times ln of a. Derivative of 2x is simply equal to 2, right? Times 2 and then dx. Or we can try to put this, I forgot, a here is 5 rather, not a. Yan, ln of 5. Next is we can try to solve for this 5 raised to 2x dx, right? Here because that is present to our integrand. So 5 raised to 2x dx is simply equal to 2 ln of 5, right? Du over 2 ln of 5. After that, let us just write this in terms of u. So this will become integral of we have du dx 5 2x raised to dx is equal to 2 ln of 5 du over u raised to 3, which we can put this constant here for the integral sign like this, and the integral of, make this u cube as negative exponent, which is u raised to negative 3 du. Okay, after, so this will become 1 to ln of 5 times u raised to negative 2 over negative 2 plus c. Simplify it, we can put the u as positive exponent. We can put this down to the denominator. So this will become negative 4 ln of 5, and our u is equal to 5 raised to 2x minus 1 raised to 2. That will become positive 2 na. And then we have 1 then plus c. Okay, you can also put the, we can also put the negative here like this. I will just copy this one, paste. Okay, 1 plus c. So this is now our final answer. So that's it for this video tutorial. Hopefully you've learned something, and subscribe to our channel for more video tutorials and problems. That's all. Thank you. Bye bye.